So now for example number 4, we're given a right triangle that looks like this. Not necessarily drawn to scale. And we are told that this is H, J, G, H, J. And we are given that this is lowercase g, this is lowercase h. We're told that this is 13, and this angle here is 25 degrees. And we're asked to find G and H, obviously. Okay. So now I identify that this is the hypotenuse. Okay. So what I can do is I can solve this by a couple of different ways. I think what I'm going to do is I'm given that the measure of angle, so let's figure out what we're given. Let's list all the things that we're given. The measure of angle H is equal to 25 degrees, and the hypotenuse is equal to 13. And that's all we have. And so what I'm going to do is I'm going to start with H. So I'm going to say sine of capital H is equal to the opposite over the hypotenuse. So in that case, sine of capital H is equal to the opposite. So what's opposite of capital H? Lowercase h over the hypotenuse, which is 13. But we know the value of h, so I really shouldn't write in h. I should say sine of 25 degrees is equal to h over 13. So what I can do then is I can actually find out sine of 25 degrees is an actual value. So I'm just going to say, in other words, it's a number. Sine of 25 degrees is 42.42. So we'll just leave it at 0.423. So in other words, this is 0.423 is equal to h over 13. So now if I want to solve for h, the only thing I need to do really is I'm just going to multiply both sides by 13, right? Because to get the 13 away from the h, I'm dividing originally, so the opposite of dividing is to multiply. Whatever I do on one side, I got to do on the other. So if I take this 0.422 number and multiply it by 13, I get 5.5 approximately. So this is about 5.5 is equal to h, and the 13s cancel each other out. So my length for h is about 5.5, and I should put the approximation symbol if I'm being good. So that's approximately 5.5. Now to find g, there's a couple different ways. I can do the Pythagorean theorem, or I can just do the cosine. So now if I do cosine, remember that cosine of 25 degrees, right? G is the adjacent. So that would be equal to g over 13. And then again, what I can do is I can go and use my calculator, and I can put cosine of 25 degrees, hit enter, and I get whatever that is, 0.906. So that becomes 0.906 is equal to g over 13. Multiply both sides by 13. So times 13. And when I multiply that by 13, I get 11.8. other words, G is approximately 11.8. And that was it. Now this had nothing to do with the inverse trig functions at all. But now if I wanted to find the measure of angle G, I forgot to mention this. We're also supposed to find the measure of angle G. Well, the measure of angle G, remember that these two angles should always add up to 90 because this equals 90. All three of them add up to 180. 180 minus 90 is 90. So these two always got to add up to 90. In other words, the measure of angle H plus the measure of angle G has to add up to 90. Well, I know that the measure of angle H is 25 degrees plus the measure of angle G is equal to 90. So then, degrees. So then I'm going to subtract 25 from both sides. And I get the measure of angle G then is equal to 90 minus 25, which is 65, right? So then this is 65 degrees. And that's it.